Hi everyone, welcome to lesson 7 for stage 5.2 equations. We're going to be looking at simultaneous equations today, and we'll use graphical techniques and algebraic techniques. So what is simultaneous equations? Or what are simultaneous equations? If we have y equals x plus 2, that's our first equation, and that's this line here, the blue line. And we have this green line as well, y equals 4 minus x, which if we graphed it would look like this, the green one. So what happens with simultaneous equations is we look for a solution to both equations. So a pair of numbers that make the equations true for both. So that point here is 1, 2, 1, 3, sorry. So you can see here the line crosses at 1, 3. This point here. So if x equals 1, we get 1 plus 2, which equals 3. So y equals 3 and x equals 1. In the other equation, this is also true. 4 take away 1 equals 3. So simultaneous equations, we've got, in this case, two equations with the same solution. Graphically, these equations are lines, and it's where the lines intersect. So this is a graphical solution that we have here, and now I'll talk about the algebraic one, the algebraic solution. So if we use substitution, we have y equals x plus 2 and y equals 4 minus x. So we've got two equations for y. Y equals this and y equals that. So for substitution, what we do is we say x plus 2 equals 4 minus x, because both of these equations equal y. And then we solve the equation that comes from that. So letters on the left, numbers on the right. So we take away 2 from both sides. 4 take away 2 is 2. And we add x to both sides, giving us 2x. Then we divide by 2. So we get x equals 1, as before. To find the value of y, we put it into either the blue equation or the green equation. So I've chosen y equals x plus 2. Same kind of thing, x can be replaced by 1. And 1 plus 2 is 3. So that gives us our y value. So graphical over here and algebraic on the right hand side. Example C. So this was A and this was B. B was using substitution. So example C, got these two equations. Graphically, we go across to 2 and up to 1 for this intersection point. So where the two graphs cross over. So 2, 1 is the solution. So this means that if x equals 2, so 2 plus 1, because y equals 1, 2 plus 1 equals 3, and 2 minus 1 equals 3. So we're looking for the pair of numbers for x and y that solve both equations. or satisfy both equations, we like to say. Algebraically, we'll use substitution again. Okay, this time around, we've got x plus y equals 3. So we're going to replace this y with what y equals. So in the blue equation, y equals x minus 1. So this part gets put into this place. So you can see here the x minus 1 bit comes from over here. So we're replacing this y with the thing that y equals over here. And then we collect like terms. X plus x is 2x. Minus 1 equals 3. Add 1 to both sides. We get 2x equals 4. Divide by 2. So x equals 2. And then again we substitute x equals 2 into one of the equations. And again I've used the blue one. So 2 minus 1 equals 1, which gives us our y value. So y equals 1. And they're the two numbers, x equals 2 and y equals 1. Okay, questions for you. So pause the video and press play when you are ready to check. We have the blue equation, this line, the green equation, which is this line. You can see graphically that they cross here. So x equals 2 and y equals 3. Algebraically, this time around we can replace the y equals x plus 1. We can substitute it for this y. So you can see here x plus 1 replaces the y. X plus x is 2x. So we get this equation, 2x plus 1 equals 5. Take away 1 from both sides and divide by 2, giving us x equals 2. Then this x goes into here to give us our y value. So y equals 2 plus 1, which is 3. So y equals 3. And the x value here is 2. So the solution is 2, 3.